Alright, so what I'm gonna do is I'm gonna just let my mouse follow or guide you guys through this process and try to explain the ETC in photosynthesis. So first we have light energy, or photons I should say, coming down from the sun and striking the various pigments within the photosystem too. And these pigments are bouncing and reflecting the light into the reaction center pigment, which happens to be chlorophyll A in this case, P680. And the electrons of the magnesium in this chlorophyll start to get excited and start to gain energy as more light hits it. And after a certain point, the magnesium is no longer able to hold on to the electrons in this um, in the photosystem. So these electrons fly off down or begin to go down this ETC. However, at the same time, this light is also exciting this water molecule enough to the point that it gives up 2 electrons to replenish the 2 that were just lost from the magnesium and create 2 hydrogen ions and 1/2 an oxygen, which will be used later for ATP synthase. But nonetheless, so these 2 electrons with very high electrical potential energy travel down from here into plasto plastoquinone, which is almost like an intermediary step before like the next destination for the electrons, I guess. It's the compound within this gets reduced and is able to pass the electrons on to the cytochrome complex. And the cytochrome complex uses the high electrical potential energy to drive hydrogen ions from the stroma out into or back into the across the phospholipid bilayer into the thylakoid inner space, which, like I said earlier, will be important for synthesizing ADP and phosphorus to make ATP. But moving on. So next we have the electrons continue to travel down, the 2 from the water continue to travel down into another membrane protein called plastocyanine, which is similar to this, also an intermediary step, like transportation step for the electrons that goes down the chain. Then the copper within this, which is why copper is a very important mineral for plants, helps pass the electrons on the chain, kind of like magnesium-ish, but it has a lot of electrons, so it's able to give them up easily. So then these electrons now go to photosystem 1, and as you can see here, the light from the sun obviously comes down and excites the electrons with bounces down from the pigments and excites electrons within the chlorophyll B magnesium, which then excites those electrons. So then they fly off and continue that chain. But those 2 electrons that I mentioned that were in here now take the spot of the electrons that were originally in chlorophyll B. So it's able to continue over and over again as long as there's reduction of or oxidation of water and the light is present. Okay, so now these electrons will travel into something called ferredoxin, which is it's basically like the other 2 membrane proteins. It's another intermediary step before it gets to the NADP reductase. And once the electron travels through ferredoxin and gets to NADP plus reductase, the NADP plus reductase uses these electrons and their energy to add two hydrogen to essentially reduce NADP plus into NADPH, which will be an important step in the Calvin cycle, or an important, or actually not important, a necessary factor of the Calvin cycle for driving that process. Okay, so now we're gonna look at these hydrogen ions and their importance to this process. So these hydrogen ions, because these are traveling as their concentration gradient against this. This is going from low to high concentration, which is why it requires the energy provided from the light. So in here there was a large electrochemical gradient created because of the high concentration of hydrogen ions. So naturally they want to escape this somehow, and this is their way out through the ATP synthase. So they will follow down the concentration gradient, and or this high potential energy will facilitate chemiosmosis through ATP synthase, and because of this very high uh, electrical potential energy, this will also drive the synthesis of ADP and a phosphorus in order to create ATP and bring the hydrogen ions back out into the stroma. And yeah, thanks for watching.